bicarbonate ion, which helps to neutralize acid in food and protect the teeth and oral tissues from decay and irritation, right? The bicarbonate ion is a base. So when acid reacts with base, it neutralizes it. Why does it matter? It helps maintain the pH balance in the mouth around 6.5 to 7.5, which is important for enzyme activity and dental health. Of course, the salivary gland also produces saliva, and saliva contain salivary amylase and ptyalin, which are what? Ptyalin is salivary amylase, which is an enzyme that help to break down starch also in the mouth. Is that okay? So that is that. Now let's see the next one. The next one we said is the production of salivary amylase, which I have said before, right? Production of salivary amylase. Salivary amylase, also called ptyalin, is an enzyme found in saliva. It works by breaking down starch, a complex carbohydrate, into maltose, a simpler sugar. Where it begins chemical digestion in the mouth before food reaches the stomach. And that was why we said that digestion of carbohydrate begins in the mouth, while that of protein begins in the stomach. Please take note of those important facts. All right. Then the tongue. Let's talk about the tongue. The tongue is a muscular organ in the mouth that help in tasting, speaking, chewing, and swallowing. Had it been get tongue, if you not feel the talk, the taste. Some of una get tongue, but not feel the taste anything. It don't happen to you before. Yes. Now, the location, it is at the floor of the mouth, the base of the mouth, located at the base, but free at the front side and sides. Now, the most important thing I want you to know about the tongue is that it has 4 taste detecting membrane known as taste bud. Then as taste bud. It has 4 taste detecting membrane known as taste bud, each more sensitive to a particular type of taste and located in specific areas of the tongue. What do we mean by this statement? Each of these 4 membrane that detect taste, they actually detect different type of taste. All right. Now, the front tip is most sensitive to sweet something. That is why if you want to taste something sweet, you need your tongue to taste that. It's sweet too. Are you getting it? And then you start chopping it. Especially those of you that buy cake. This cake is sweet, or you lick ice cream. You use your tongue to lick ice cream. I don't know. Why? Because that front part of the tongue is what tastes sweetness. Then the back of the tongue tastes bitter things. You cannot use your tip of tongue to know whether something is bitter. You have to want to swallow it before you come. This thing is bitter. Are you getting it? So the back of the tongue tastes bitter. Then on both sides of the tongue, that is by the side, they detect sour substances. Are you getting it? So if this is the tongue, what will they tell you? They say this front side na sweet thing, if they detect. This back side, if they detect bitter thing. Why these 2 sides like this? They taste sour things. If something sour, and these 2 sides they detect them. Is that okay? Exactly. Now, together, these taste buds work to help us experience the full range of flavors in food and drink. Now, let us talk about digestion in the mouth. We say digestion in the mouth is the first stage of digestive process, where food is mechanically and chemically broken down to prepare it for swallowing and further digestion in the stomach. We've looked at all these things before. Now, like we said, there are 2 types of digestion. We have mechanical digestion, and then we have chemical digestion. Mechanical digestion is by the teeth and the tongue and the saliva and those things that are present there. The teeth cut, tear, and grind the food into smaller pieces. This increases the surface area for enzyme to act on. The tongue helps mix the food with saliva and roll it into a bolus. So bolus are found in the mouth. Emphasis on this bolus here. This bolus here, take note of it. A mix of saliva and food in the mouth is called a bolus. A soft round ball of food for easy swallowing is called a bolus. In the mouth, it's called a bolus. In other part of the body, it's called a different name. But the food in the mouth already mixed, already rolled into a ball, is called a bolus. Emphasis on that. So that is for the mechanical digestion by the mouth. Now we have chemical digestion. Like I told you that anything digestion is 2, mechanical and chemical. The chemical digestion, the salivary gland releases saliva, which contain water and mucus to moisten and lubricate the food. We've talked about that. Salivary amylase like ptyalin, an enzyme that begin the breakdown of starch, complex carbohydrate into maltose, a simple sugar. We've talked about that. Now, after digestion in the mouth, the food becomes a moist bolus. It is then pushed to the pharynx and down the esophagus by swallowing. It goes down. Are you getting it now? Then digestion in the stomach. From the esophagus, this thing has to go to the stomach. But there is what we call a cardiac sphincter rather, cardiac sphincter. This cardiac sphincter is also called lower esophageal sphincter. This esophageal sphincter, what is its function? The esophageal sphincter is located at the junction between the esophagus and the stomach. Now, what is its function? Is to ensure that food do not come back, to ensure that the food, once the food pass, it closes up, to ensure that there is no regurgitation, except in abnormal cases where some persons start regurgitating the food they've already swallowed. All right? That is the use of the sphincter. That cardiac sphincter ensure that the food passes in one direction down to the stomach without what? Regurgitating it. Is that okay? It opens to allow the bolus to enter the stomach and then closes to prevent the stomach acid from going back up into the esophagus, like reflux. That causes, there's a condition that actually happens, which we call the esophageal reflux disease. Or, yeah, gastroesophageal reflux disease, GERD. All right? The situation where it is when you don't already chop, they cause burning of your chest and tightness. All right? But that is the work of this cardiac sphincter in the stomach. Now, mechanical movement. We talked about peristalsis when we talked about the churning effects of the mechanical movement, peristalsis. The stomach was contract in rhythmic wave called peristalsis. Like that contraction, boom, boom, boom. And the stomach, they contract like that. The food, they move down. Peristalsis churns and mixes the food with gastric juice, helping to physically break it down into smaller particles. Now, gastric juice secretion. These are the things that happen in the stomach. First of all, the food enters the stomach via the cardiac sphincter. Then there is peristalsis, the movement of the food in the stomach. And that movement, the peristalsis, ensure that the food mixes with gastric juice. Now, gastric juice secretion. When bolus enter the stomach, it stimulates the stomach lining to release gastric juice. Immediately enter inside the stomach, it dey make the stomach lining to release the gastric juice. Are you getting it now? Gastric juice is a mixture of hydrochloric acid, and it creates an acidic environment of pH approximately 2, which makes the stomach to be highly acidic. Now, what is the function of that gastric juice that is secreted by the presence of that bolus? It kills harmful microorganisms and it activates enzymes for digestion. Now, what are some of these enzymes that this gastric juice activates? Let's look at them. We have also the mucus present in the stomach prevents the stomach itself, prevent the acid itself from affecting the walls of the stomach. Now, there are two important types of enzymes that you find in that stomach. Pepsin. Pepsin break down protein into smaller peptide. It is first of all secreted as pepsinogen. If you watch the video on enzyme, I said pepsinogen, when you see things like pepsinogen, angiotensinogen, all these ones, they are inactive and activated by something. The pepsinogen is, once hydrochloric acid is present, it activates the pepsinogen to pepsin. And this pepsin will now break down protein into smaller peptide. You get pepsinogen is present there, but you know they work, it just did there. But because, first of all, bolus come, what do we say bolus go do? It go lead to secretion of what? HCl. This HCl now will now do what? We now act on pepsinogen hmm, and convert the pepsinogen to what? Pepsin. This pepsin now will now break what? Protein into what? Amino acid, or into peptide, smaller peptide first before break down into amino acid. Are you getting the how the whole process is taking place? Then also renin. Renin help curdle or coagulate milk, making it easier to digest. Renin in infants helps curdle or coagulate milk, making it easier to digest. Please take note. Which of the enzyme in the stomach helps to coordinate, curdle, or coagulate milk? The correct answer is what? Renin. Emphasis on this. Take emphasis on this one. Are you getting it? Then renin acts on casein, the main protein in milk. The main protein in milk is casein. Now, so that is the activity that takes place in the stomach. We said the stomach, there are mechanical activity, peristalsis, then the chemical activity, that is where you have the gastric juice secretion, and then actions of enzymes such as pepsin and renin. Then let's talk about the small intestine. After food is partially digested in the stomach, remember that in the stomach it has been partially digested by the enzymes, right? It enters the small intestine for final digestion and absorption. Now, the food that contains this gastric juice already mix with the food substance that have been partially digested rather, if I say digested is called chyme. That means the one leaving the stomach, that food when they come out for the stomach, they call am chyme. The one when they come out from your mouth through the esophagus, they call it what? Bolus. The one from your stomach into your small intestine, they call am wetin? Chyme. Are you getting it now? There's also a sphincter that ensure that the food gets to the small intestine and don't come back to the stomach. That sphincter is called a pyloric sphincter. The first one we talked about was cardiac sphincter or lower esophageal sphincter. This one is called a pyloric sphincter. It's like a passage that allows the food, the chyme, to pass through, but does not allow it to go up. That means from your stomach to your small intestine, you have the chyme. What regulates it is the what? Is the pyloric sphincter. All right? From the stomach into the small intestine. Now, there are three regions of the small intestine. The small intestine has three regions. We have the duodenum, is the first and the shortest. The jejunum, the middle section, and the ileum. DJI. Just know this one. DJI. Duodenum, jejunum, and ileum. They may ask you, what are the three regions of the small intestine? The correct answer is what? Duodenum. In the order, remember DJI, duodenum, jejunum, and what? And ileum. In this order. Is that okay? Duodenum and associated organ. The liver produces a digestive fluid called bile. Like we said, the bile is stored in the gallbladder and it is secreted into duodenum through the bile duct. What is the properties of this bile? The taste is bitter. It is greenish yellow. What is the function of the bile? I said the function of the bile is for emulsification of fat. It's more like to allow fat to mix with water in the stomach, or to allow fat mix with the content of the stomach. You know, fat does not mix with water. Are you getting it? So that bile now will make that fat to mix with the content of the stomach, mix with the enzyme. You know, those enzymes, they work in aqueous medium, right? So for any enzyme to act on fat, it must the fat must ensure that it is mixing with water molecules. Since enzyme, most of them work with water, hydrolysis. Is that okay? So that bile now is like your akawu. Oil and water no dey mix, but once you put akawu inside, go do wetin e go mix. Are you getting it? Fat and the enzymes will not mix Are you getting it? But you need that enzyme to break down fat. So in order for that fat and enzyme to mix, you use the bile. And that bile is secreted by the liver. That is where liver comes in. Liver not dey do any other function na just e dey produce this bile, which will now be stored in the gallbladder and then secreted into the duodenum by the bile duct. Are you getting it now? For emulsification of fat. We said emulsification is like the mixing of fat and oil, fat and water together. Now, emulsification of fat break down large fat droplet into smaller ones, increase the surface area for enzymes to what? To act. Is that okay? This makes it easier for lipase, a fat digesting enzyme, to work. Do you understand? So you should know that. Now you discover that most of the things we're talking about, digestion of fat takes place in the where? In the small intestine. You see how it goes. Protein, a carbohydrate in the mouth, protein in the stomach, fat, small intestine. Are you getting it? The pancreas also secretes pancreatic juice into the duodenum through the pancreatic duct. The pancreatic juice consists of amylase, which break down starch into maltose, of course, you know. Lipase break down fat into fatty acid and glycerol. Take note of this. They may ask you, lipase breaks down fat into what? Fatty acids and glycerol. That's the correct answer. Lipase breaks down fat into what? Fatty acids and glycerol. That is the correct answer. Is that okay? Exactly. Then trypsin breaks down proteins into peptide. These are the chemical processes that takes place in the small intestine. Let us summarize. What did we say happened in the small intestine? First, we have three parts of the small intestine. First of all, chyme enters into the small intestine via the pyloric sphincter. Are you getting it? Then there are three distinct, which is duodenum, jejunum, and ileum. Now, the liver produces a digestive fluid called bile, which is stored in the gallbladder and then secreted into the duodenum via the bile duct. The bile has a taste that is bitter and is greenish yellow, and the function of the bile is to emulsify fat, like mix fat with water, to ensure that what happens. Hear this? Okay. To ensure that what happens, to ensure that the enzyme can easily act on lipid molecule or fat molecule to break them down into what? Fatty acid and glycerol. Now, we also said that inside the small intestine too, that same pancreas also secretes some pancreatic juice into the duodenum. The pancreas is close by, so it also secretes this pancreatic juice into the duodenum that help to break down food inside the duodenum. And these pancreatic juice are amylase, lipase, and trypsin. Amylase breaks down starch into maltose. Lipase breaks down fat into fatty acids and glycerol, while trypsin breaks down protein into peptide. Is that okay? Then we have the jejunum. It continued chemical digestion using enzyme from the small intestinal wall. Then the ileum. The final stage of digestion occurs in the ileum. Absorption of digested nutrients like glucose, amino acid, fatty acid into the bloodstream through finger-like projection called villi and microvilli takes place in the ileum. Are you getting it? Through the word villi and microvilli takes place in the ileum. That is where digestion and absorption also take place. After this, only undigested material and water are left to pass into the large intestine. So there's no digestion that takes place in the large intestine. More like a storage place where you store things when not digest and water pass into there. So they may ask you which part of the small intestine particularly does absorption or digestion and in the ileum. Are you getting it? Then the villi. We say the villi are tiny finger-like projection found in the inner walls of the small intestine, especially in the ileum. The function is each villus contain capillaries and a latia, a small lymph vessel. They contain blood capillaries and a latia, a small lymph vessel. The capillaries will carry food to the blood. While this latia will carry food, will carry the nutrients to the what? To the lymph. Are you getting it? Every villus contains these two things. the blood vessel, which is a capillary, and the latia, which is a small lymph vessel. They increase the surface area for maximal absorption of nutrients. The digestion of nutrients involves specific enzymes that break down complex food into, we've talked about that. Starch is digested by the enzyme, which we've talked about. This enzyme break down starch into glucose, which is then absorbed into the bloodstream through the blood capillary in the villi of the small intestine. So for glucose, it goes into the blood capillaries. Fats are broken down by the enzyme lipase, which acts to convert fats into fatty acids and glycerol. Emphasis on this. Fats break down to give us fatty acid and glycerol. These products are absorbed not into the blood, the fat and the glycerol, they are not absorbed into the blood, but into the lacteas, which are small lymph vessels found within the villi. So the fatty acids and glycerol, they don't go into the blood. They go into the lymph. Are you getting it? Proteins are digested by enzymes such as pepsin in the stomach and trypsin from the pancreas. Trypsin works from the pancreas. This enzyme breaks down protein into amino acids, which are absorbed through the blood capillaries into the villi. All right. Then the storage organs, like we said, the storage organs are, we have duodenum, ileum, the stomach first. Stomach is part of them. Duodenum, ileum, and colon. These are the storage organs. All right. Duodenum, stomach, duodenum, ileum, and colon. And I think this is everything you need to know. Emphasis on these fatty acid, fat broken down into fatty acid and glycerol. The pepsin works as an enzyme, works in the stomach, while trypsin works in the small intestine. Absorption takes place where? In the villi. Absorption takes place where? In the villi of the small intestine. Please take note. Absorption takes place. The digestion ends where? In the small intestine too. Absorption takes place where? In the villi of the small intestine. Emphasis on that. Then we said the fatty acid and glycerol, they don't go into the bloodstream, but rather latia, they pass through the latia into the lymph. Are you getting? Then the storage organs are stomach, duodenum, ileum, and what? Colon. Colon is for large intestine. Ileum is for small intestine. Duodenum is also for small intestine. Then, of course, we have the stomach. So that is basically that for this particular one. We'll see in the next one.